Hello students. In the previous video, I have given passing package for second PU electronics. I hope it was useful. As I could go through the paper 2022 electronics board paper, I could see around 23 marks. The questions have come from that video. I hope most of you have done well. This is the answer key for the electronics 2022 board paper. I hope all of you have finished your exams. Yesterday the complete examination got over. I didn't want to disturb you all during your exam days because still Hindi exam was left over. That is why I didn't upload this electronics answer keys. Also, I hope all of you have noticed from the previous video, that is passing package questions, important questions, from that video around 23 marks questions have come in this board paper. So let us see the answer keys for electronics question paper, board paper 2022. This is Jyoti HS. Those who are watching my video for the first time, do subscribe my channel, hit the like button, press the bell notification icon, share this to your friends. If in case any supplementary students are there, for them it will be useful. Also, those who are passing second PU and going for your higher studies, BSc, engineering, anywhere where you are studying electronics or taking electronics stream, there also these videos will be helpful. This question paper contains 5 parts: part A, part B, part C. Part D is 2 parts, that is part D1 and part D2. Part A contains 15 questions of 1 mark each, wherein you need to write 10 questions. But you are not restricted that you need to write exactly 10. This is state board, you can write extra questions. Best 10 will be chosen by the evaluator. Similarly, part B contains 10 questions, carries 2 marks. You need to attempt only 5, but you are eligible to attempt all. Best 5 will be considered. Best 5 in the sense, suppose you got 2, 1, 2, 2, 0, 0, 1, 2, like this. 1, 2. Suppose you have attended all the 10 questions. Then we choose only those which are having 2 and the remaining we write it as extra. Same thing will be followed for part C, D1 and D2 also. Part C contains 10 questions of 3 marks. You need to attempt 5. Best 5 will be taken if you have written extra questions. Part D, first main, is a problems section which has 6 questions of 5 marks each. You need to attempt 3 questions. Extra questions are considered, wherein best 3 will be taken. Part D is also of 5 marks. Part D2 contains 6 questions of 5 mark each, wherein you need to attempt 4 questions. Extra questions are considered, best 4 will be taken. This is just a simple overview of the question paper. Let us see part by part. In this first video, I will be giving answer keys or answers with little explanation wherever it is required for part A and part D. Otherwise, this video will go more than 1 hour. It will be difficult for you also to watch. So, whichever section you need, you can watch. After that, I will do separate sections, separate videos for part C, D and part D1 and D2. So, let us see part A questions first. In part A, question number 2, 4 and 7 were highlighted in the second PU passing package video. Draw the circuit symbol of N-channel JFET. The circuit symbol looks like this. Students, in case if the arrow mark is like this, then the same thing will become P-channel JFET. So I'd like to give both the symbols here so that it will be helpful for you to understand. If the arrow mark is towards the system, then it is N-channel JFET. If the arrow mark is outwards, then it is P-channel JFET. Here it is asked N-channel JFET, so this is the right answer. Name the biasing circuit which gives excellent stabilization. It is none other than VDB, that is voltage divider biasing circuit. This is also known as self-biasing circuit. Let me choose different color. Self-biasing circuit. Why CC amplifier is called as emitter follower? Because emitter voltage follows base voltage, that is the output voltage follows input voltage. That is why it is called as emitter follower. What happens to output impedance of an amplifier when voltage series negative feedback is applied? See, feedback amplifiers, this is an amplifier, this is a feedback network. An amplifier, you know very well, it has output and it has input. Now when I say voltage series negative feedback, the circuit will be like this. This is series part, that is series will become input. When I want to tap voltage, it is parallel. When there is a parallel connection, when two resistors are connected in parallel, you know very well the resultant will decrease. So it is asked output impedance, hence it decreases. Then the next question, sketch the output waveform of op-amp integrator if square wave input is applied. So this is the input voltage, square wave, this is the output voltage. According to the formula, you know VO is equal to minus 1 by RC integral of sine omega t d omega t, that is sine theta d theta. In this case what happens? Minus 1 by RC. You know very well, since you all have studied integration now, so integral of sine will be minus cos theta. So this is the integration. So minus and minus becomes plus and you are getting cos of omega t by RC. That is why you are getting plus at the output. So you have to start from here. So this is what is the output waveform. Which principle is used in crystal oscillator? It is piezoelectric effect. Okay, next is define skip zone. It is the region around the receiving antenna within the skip distance where neither ground wave nor sky wave is present. Suppose if this is the transmitting antenna and on the other side you have a receiving antenna. This is line of sight. This is ground wave loss, ground or ground. Next one is ground reflected wave. You could see this is the in and around area near the receiving antenna where none of these signals are there. So that in this region no communication, no transmission or reception is happening. This region is called as skip zone. More detail you can check the link provided, wherein wireless communication chapter. The video description is shown in the right corner. Click the link to go through the channel. Next question, write the expression for modulation index in terms of Vmax and Vmin. It is given as Vmax minus Vmin by Vmax plus Vmin. Always remember positive sign should be at the denominator. If denominator is greater than numerator, then the value will always be less. So this is the key to remember. How many sidebands are present in FM wave? Frequency modulation will have infinite sidebands. Then expand IGBT. You need to expand the words IGBT, insulated, gate, bipolar, transistor. You can even write bipolar junction transistor. Write the output boolean expression for the 2 input XOR gate. Usually we write A XOR B. Instead of this, it is better to write like this: A bar B plus AB bar. Then convert 1011 gray code into binary code. 1011. So what we need to do is we need to keep the MSB. This is MSB as it is. This is gray code. What I am writing is binary code. Then I need to do this diagonal XOR or addition. 1 plus 0, that will be our 1 XOR operation I need to do. XOR means 1 XOR 0 or 0 XOR 1. For these two it will be 1. Or if suppose 0 XOR 0 or 1 XOR 1, the output will be 0. This you need to remember. This is the truth table of the XOR gate. So now 1 XOR 0 means it is 1. Then again I need to do these two. Both are high, so the output is 0. Again I need to do 0 and 1. I am getting it as 1. Diagonal XOR gate operation we say. So the answer is 1101 binary. You can write only this, but you should do this mentally, or you can write it aside and write this. Then the 13th question is, how many serial ports are present in 8051 microcontroller? It is only 1. Write C equivalent expression for y is equal to a square plus b square. Y is equal to a star a plus b star b. You can put a bracket, or simply you can write a star a plus b star b also. What is meant by fiber optic communication? You know, optic means light, communication means transmission of information from one place to another place. Fiber means it is a wire or a pipe. So, if you know these individual meanings, you can frame the definition. A fiber optic communication system uses light wave as the carrier of information. That means through light we are passing the information to transmit the data over a fiber by changing electronic signals into light. In this, sometimes we use LED light, sometimes we use laser light as a source of information or a carrier signal. This is about part A. Part B, we will see, that is 2 mark questions. The first question, define amplification factor. This question was also highlighted in the video. So in this, define amplification factor means it is the ratio of small change in drain source voltage, that is VDS, to the corresponding small change in gate source, that is VGS. Obviously I need to keep ID constant. It should have been like this, ID constant. So if I have to write it in equation form, mu is equal to small changes denoted by delta, delta VDS by delta VGS at constant ID. Then the relation is mu is equal to RD into GM. Then write the steps to draw DC load line for a transistor. This is also given in the video, but the question was like, derive an expression to find the Q point or DC load line coordinators. Here it is asked to write the steps. That means you need to know, draw DC load line, not to determine the coordinates. You have the coordinate points. Now how to draw this load line? First of all, draw output characteristics of a transistor. You can even write the output curve, or simply write this, that is y-axis contains IC, x-axis contains VCE. Write their voltage, write their units too. After this, you need to mark the end points. Mark the end points such as VCE is equal to VCC on x-axis, IC saturation is equal to VCC by RC plus RE on y-axis. Then draw a straight line joining these 2 points. A very simple explanation. You can put it in your own words. You need not have to draw this. This I showed here just to understand. So only the steps you need to write. Then next question, draw AC equivalent circuit of a single stage CE amplifier. You know, AC equivalent circuit is also called as RE model. Base, emitter and collector. Emitter is grounded. This part forms the input. This part forms the output. So input sides has R1, R2 and beta Re dash 3 resistors in parallel with input voltage. Output side a current source RC and RL. Then what are the advantages of negative feedback? This was also been expected. This was also been highlighted in the passing package video. There are plenty of advantages of negative feedback except only one disadvantage. What are those things? Let us see. So the advantages of negative feedback are less distortion and reduced noise level. You can write it as 2 points. I have given it as 1 point. Highly stabilized gain. Flat frequency response. The frequency response, that is, instead of giving like this, frequency response will be like this. This area will be more flat. As the curve becomes more and more flat, and better linearity will be there for the circuit. Because of that, bandwidth also increases. Input and output impedances can be modified. Why I said input and output can be modified? Because I don't know what type of negative feedback am I giving. Is it voltage series, voltage shunt, current series or current shunt? If I take the syllabus voltage series, then I can say increase the input impedance and decrease the output impedance. You remember one more question that was asked. So the only disadvantage, anyhow it is not asked, but for your knowledge I am telling, the only disadvantage is it reduces the gain. Then mention characteristics of an ideal op-amp. In this, actually speaking, any two can be mentioned because it is for 2 marks. There are around 8 parameters. Since I am giving answers, I will not stick on to only 1 or 2. But as a student, if you want to answer for this question, you can write only 2 or maximum 3 parameters. If one goes wrong, then other will be there. Also, you can just name, because it is only mention, just because for your understanding I am giving it like a table wherein what are those symbols, what are those ideal values. So anything if they ask, even for 1 marker, this is for revision students, those who want to revise their papers, maybe those who are writing supplementary exams, or maybe the upcoming second year students, those who are writing their exams in 2023 or any other further exams. For them it will be helpful. That is why I am giving all the parameters. But you need to write any 2 only. That 2 you need to write, or only you need to mention. So open loop gain, input impedance, common mode rejection ratio, which is usually we call it as a CMRR, bandwidth, slew rate. All these 5 ideal value is infinite. Then output impedance, input offset voltage, input offset current, input bias current, all these have 0 as their ideal value. Even the symbols I have given, usually these are the symbols we use: CMRR, bandwidth, input impedance is Zin, open loop gain, O stands for open, L stands for loop, A for gain, open loop gain, slew rate, SR, like this the symbols are denoted. Any 2 is enough, or max to max any 3 is enough, since it is a 2 mark question. Then the next question, state Barkhausen criteria for sustained oscillations. There are 2 conditions which are known as Barkhausen criteria, and the first one should be the loop gain A beta should be 1. We write mod A beta should be 1 because when I use this formula 1 minus A beta, it should be 0. So irrespective of A beta, which is equal to minus 1 or plus 1, I want this to be 0. And you know, for positive feedback, AF is equal to A by 1 minus A beta. as 1, what I will get is A by 0, which is infinite. So without the input voltage, it can produce oscillations. Input voltage in the sense AC voltage is not given, DC is given for biasing, but still oscillations will produce. And to sustain that oscillations, overall phase shift between input and the feedback signal should be 0, or simply I can say it should be in phase, or positive feedback should be applied to the circuit. Barkhausen criteria to have sustained oscillations. Draw the block diagram of basic electronics communication system. Again, this question was given in the video and it has come. I have given it in 3 mark and explanation I had given, and also there I mentioned if it is only diagram it is for 2 mark. So the simple block diagram is information or source. That is what I am talking to you is the information. Through the net, YouTube, whatever it is, we are transmitting. Again, in this transmitter there are many circuits, modulation, filtering, processing, amplifying, everything is there. It is been sent through transmitting antenna or wired communication like cable TV connections. It is received by the receiving antenna, and between transmitting antenna and receiving antenna there is a channel. In this channel, radio communication we have. This is an open space between transmitting antenna and receiving antenna. Space acts as a channel here. Hence, atmospheric, any place you can get interrupted with noise. So noise will be written in this channel. Then the signal is received by the receiver, where demodulation, processing, filtering, amplification is being done, and then giving the original signal to the destination, and the destination will be loudspeaker. In case if it is a television, along with microphone we will have camera at the input, and along with loudspeaker we will have a screen at the output. So this is about the block diagram. I have given explanation also. There you need to just draw the diagram. You need not have to do any explanation. What are the characteristics of a good receiver? See, suppose this has to receive the signal, what are the abilities or qualities that receiver should have? That is selectivity. It should be able to select the desired signal. Sensitivity, even if the signal is weak, it should be able to sense that and receive that signal. Fidelity and stability. It should give accuracy. Fidelity is accuracy. It should give accurate signal. Stability is as long as the input is present, the output should be present. There should not be any disturbance at the output. These are the 4 characteristics that a good radio receiver should possess. This comes in the chapter demodulation. Then the next chapter question is distinguish between punch through and non-punch through type of power diodes. I have given here with the table type. You can reduce this and write for 2 mark. Since I have to give the complete explanation, I have given this. Punch through diode. See, I'll just show you the diagram here. What has happened? A power diode will have a P plus region and an N plus region. In between there is N minus region. So N minus region is lightly doped, P plus and N plus is heavily doped. Obviously the depletion region will be more towards the lightly doped region. When I say punch through diode, the depletion layer spans entire drift region. That means the complete N minus region is occupied by the depletion region, and it will make contact with N minus layer. This is the border between N plus and N minus. Up to here the depletion layer spreads up, but very less or negligible penetration of depletion layer into cathode region. That means very less, or it won't go to N plus region. Hence electric field strength, this is one point, and this is another point you need to mention. Hence electric field strength in punch through power diode will not be 0. If you see at this junction, it is not 0. It has some potential difference. Some barrier potential will be here, but which is less than this. Wherein if you go to non-punch through diode, The first point is the depletion layer's boundary does not reach the end of the drift layer. That means it won't touch N plus region. Could you notice this is the empty space left out? The depletion layer will be much more before N minus region ends. Then again, because of this, what happens? The electric field strength is maximum at P plus side and decreases to 0 at N minus region. That is between the border of N minus and N plus, it becomes 0. You could notice that this is a gradual decrease, but here there is no 0. It won't reduce to 0. Then next question, mention few types of protocols used in computer networking. Many would have got confused with this. This is a modern communication chapter, and in this the few protocols I had given explain or expand IP, TCP, all those things. It is a part of that only. Question is been asked in a different way. This was also given in the video. So before I go to the types, I would like to say what is protocol. A protocol is a set of rules that are procedure that will be used by the system for communication. There are many protocols wherein few important ones are TCP. This is what I had given in the video. Transmission Control Protocol, Internet Protocol, File Transfer Protocol, HTTP, most of you are aware about this, Hypertext Transfer Protocol. So this is about part B and part A, questions and answers. I hope many of you have done well with these questions. In the next video, let us see part C questions, which are of 3 marks. And after that, I will do part D problem sections and part D2 theory sections. Those who are watching this channel for the first time, please do subscribe my channel, hit the like button, press the bell notification icon so that any new updates will be intimated to you. Thank you for watching.